Ugh. There we go. Next semester, the plan, you know how you guys are kind of half on, half off a little bit, alternating days. Next semester, the plan is to have you all, like if what we're doing next semester, we would have done this semester, we would have had everybody here for pre-cal like Monday, Wednesday, and then remote on Tuesday, Thursday for everybody. So they're looking to get people more together. Just occurring to me now though what SLG is going to look like. And then I need desks in the room. Anybody at home still writing?
No, I'm good.
Thank you.
I'm good too.
Cool. Micah?
I'm done.
Jamer, are you done?
Yeah.
Maya? Okay, now it's probably a good idea for you to write down Pascal's triangle, but before you do, let me just kind of mention it. It's a good idea to write it down because you will not be given this triangle on tests. It is good to know it, and it's good to know how it works. And it's not so much a memorize as it is a know-how. Start with a 1, like you can see that's all 1s on the outside. Start with a 1, and then 1, 1, and then each number below is the sum of the 2 numbers above it. So for example, like it's always going to be 1s on the outside because it's 1 plus, and there's nothing there. But the 2 is 1 and 1. These form this kind of triangle here. Okay. And then 1. So you have 1, 2, 1. Underneath it, it's going to be 1 and the 3 because of the 1 and the 2. And then the 1 and the 2 make this 3, and then 1. And it continues on. The 4s from the 3 and the 1. 6 from 2 3s, etc., etc., etc. Why you need to know that, I'll share in a bit. Maya, did you have a question? Was I going to answer a question started today, or am I thinking of last week? Okay. Cool. All right. I was thinking something that we were going to talk about before class started, but yeah, I guess it was last week.
My sister's here today.
Okay.
And I told her.
Thank you. Karina, remind me to make a note to myself about talking to Mrs. Smith about schedules next semester.
Remember to talk to Mrs. Smith about the stuff.
You don't have to mock me humming and hawing while I'm trying to think. But thank you for the reminder. Oh, I hurt my back yesterday, you guys. Sucks. Shoveling. Just stupid. Not shoveling, chipping ice. So I don't know what I did. I don't know what I did. Anybody at home still writing?
Nope. No.
No.
Maya, are you still writing? That's a lie. I can see you writing right now. It's just not notes. Okay, that's fine. I'm just teasing. Okay, now this, you don't need to write this down, but it wouldn't hurt. Notice it says, ugh, get out of the way. At the very top, holy moly, just at the very top, what you're missing, see, you can see by the order here, this is a plus b to the power of 0. That equals 1. A plus b to the power of 1 is just a plus b. We still have these numerical coefficients. You wouldn't need to write them in. You know, if you have an answer of a, you don't need to say it's 1a or a over 1 or anything like that. But it's just showing you how Pascal's triangle works. A plus b squared, this will be your final answer. And this isn't just a plug and play memorizing thing. It won't always work this kind of neat and clean, but it gives you an idea of the patterns. And we're going to look through that. I'll put all the notes and then we'll take our time looking because it's interesting and important, you know, like all the good things in life. And if you want to just reference that, like the graphic at the top right, that's on the bottom of 291, if that helps, if you'd rather just reference it. Oh, well, it's minus 28 right now. That's pretty cold. Single digits on Friday. Hard to depress. Been spoiled with my Prius. Almost never plug it in. How come? Doesn't have a block heater?
I bought it used.
You know, I thought a block heater, I don't know much about cars, but I have a son who does. I thought like a block heater was kind of a part of the block, like it had to be bolted inside or something. But Jackson bought a car, didn't have a block heater. So he bought a block heater and it just kind of magnetizes to the bottom. Like it's just a 5-second job. I thought it'd be a massive thing. What kind of car do you drive, Maya?
2006 Toyota Yaris.
Oh, little thing.
Yeah,
And it's a standard?
Yeah.
Nice. What are you driving, Gavin?
A newer years.
Oh, yeah? What color?
Silver.
Mine's also silver.
Oh. Do you guys park anywhere near each other and go to the wrong car every once in a while?
I don't think so.
I park in the back. My license plate is compete. So
Okay.
no one's gonna know that.
Did you, was that your vanity plate or your parents give it to you? Yeah.
No, I got a personalized plate.
This one friend of mine, she's a girl. And anyway, I don't know why that's important. She's got 2 other sisters. And her mom got them these vanity plates. So Dawn, this friend of mine, she's an art teacher. And her vanity plate is artsy one. They have this really athletic sister who's got athletic scholarships. She's sporty one. And then the other one is a dance teacher. And so it says dancy one. But the dancy one, she says she gets some looks thinking she's some kind of entertainer or something. She doesn't love it, but
Yeah, the Yaris is not exactly like the most fun car to drive. I think.
gets you from A to B though, I bet.
Yeah.
I like that.
Yeah. I like little cars.
Me too. Except when you get stuck.
Sure,
Not fun.
sure. But it's easy to push out.
Yeah, that's true.
You know, you can push it out yourself. I used to deliver pizza and had this Maverick, which wasn't a little or light car, but that's not the point. The point is getting stuck delivering pizza, and it didn't have pausey, like the back wheels would turn independent of each other, and the one that would turn, sometimes only one would turn, and that's if wherever the least resistance was. And so if you're on ice, one would spin, you couldn't kind of go anywhere. And I got stuck once delivering pizza, and I was like, what am I going to do? I'm all by myself. So I left my door open, left it in drive, and so the back wheel's just turning slowly. And then I get out behind him, rocking it. I make sure the front tires are straight, by the way. That's important because I get it out and it goes. So I had to run and jump in. All right, some people in class here are still writing, but in a couple seconds, I'll start kind of talking my way through this a little bit. Okay, seconds are up. So I'm gonna use this pointer. So a plus b is any binomial and n is a natural number. So like 0 and up, whole numbers 0 and up. Now with these, it's worth mentioning with these numerical coefficients, it changes if one of these is a number. Like if this is like 6 plus k or something like that, then these numbers in front will multiply that number. But if it's just letters, so here's some things that we need to look through. The sum of the exponents within each term equals n. So this is n is the exponent. So for this one, a plus b to the 0, there's no exponents here, or it could be 0, so it adds up. Here, the exponent is 1. So in each term, it adds up to 1. So it's a to the 1 and b to the 0, b to the 1, a to the 0. When it's squared, adds up to 2. Each of these has 1, adds up to 2. Jump to the bottom for 5. The first one, a to the 5. And then notice the pattern. A to the 4, b to the 1. A to the 3, b to the 2. A to the 2, b to the 3. A to the 1, b to the 4. A to the 0, b to the 5. Okay, so there is an order. There is a pattern here. These numbers, the 1, 5, 10, 10, 5, 1, these are all part of Pascal's triangle. Notice also, I'm going to say stuff and then go back and it's going to be written in the notes. But like, so a plus b squared, it's to the 2. The second term, the numerical coefficient is a 2. I'm saying this because every once in a while you might kind of forget, oh, which level of the triangle am I at? A plus b to the 5. The second term is a numerical coefficient of 5. Second one's 4, 3, 2. See the pattern? Notice how the exponents increase, decrease each term. We talked about that, how like the leading one goes down and the second one goes up. The polynomial a plus b to the n has n terms. So when it's to the 5, 1, 2, wait, what? It has n plus 1 terms. That's wrong. Sorry. Sorry, you guys. N plus 1. Where am I? Right. Okay, sorry, it has n plus 1 terms. So when it's to the 5, then it'll have 6 terms. 1, 2, 3, 4, 5, 6. It's got n to the 3, or n equals 3. 1, 2, 3, 4. First and last terms have coefficients of 1 and powers of n. So to the third power here, 1a cubed, the final one is 1b cubed. 1a to the 5, 1b to the 5. When it's at 1, 1a to the 1, 1b to the 1. If a and b are positive terms, all terms are positive. If b is negative, get out of here, that little thing, move. If a and b are positive terms, all terms are positive. If b is negative, its odd powers are negative. So every second one is negative if a and b have different signs. Questions about this slide? A lot of this, it's one of the things I realized with Precal is you learn more through the examples. So the notes I think learning are much less. This one, there just has to be a lot. It'll make sense as we're doing it, but this is stuff you can refer back to. I don't expect you to look at this and go, okay, I got to memorize all this. No. This craziness, by the way, where's my red pointer? Why does it keep going away? This craziness, you'll be given this. There's a kind of a bit of a different one that they give you kind of for provincial exam, that's on the formula sheet. So if you look at the formula sheet and go, wait a minute, this one's different. This is the one I will give you for what it's worth. This will be given. You just need to know what it means, that the R is the Rth term. And the reason it says like Rth term, it sounds really odd, is because you might be given, like, so I just made up this one, k minus 4 to the 11. If you were to expand this, and you will be asked to expand, but not one this to this high an exponent. This will be 12 terms. It'll be really big and it'll take forever. But you could be asked, what is the third term in k minus 4 to the power of 11? And that's what this is for. You could be asked for the third term in k minus 4 to the power of 960. I hope not. But so that's, instead of doing the whole thing and then figuring out which one it is, this, you can just pull out the one. You will be asked to expand bigger ones as well, though. I was going to say something else, but I don't remember. Oh, and this part here, like, so this is combination theorem stuff. So to figure out which term it is, this will tell you what the numerical coefficient is in front. That's what this is all about. This tells you the exponents that go with each of these. Does that make sense? This is the number in front. And then this is a to the something, b to the something. That makes sense? All right, we ready to look through some examples and stuff? Also, it's worth mentioning, not worth mentioning, I have to mention, I meant to mention this the beginning of class and I forgot. I would very much like for you to have a look at Power School and tell me what you think your mark should be for this semester by Wednesday. I'll put it on Classroom. Karina reminded me to put it on Classroom. I'll put it on Classroom. Please have a look at Power School and don't think, okay, well, first semester I got this, second semester I got, ignore kind of what your first semester mark was. This is the year that we're marking now. And some of you have gone back and you've improved certain things. So look at it as a big picture, the year. What do I think my my mark is? I will figure out what I think it should be, and then we'll fight to the death and decide on final mark. Questions about that? All right, I have this, I wrote this down just because I don't have that memorized. And we'll probably refer to it. Okay, so the very first one we're looking at is bottom of 292. It says, this is page 292. It says expand x plus 5 to the 4. Now, some things that you, I hope, will start to see, you might not like instantly, but like this, there will be 5 terms because there's always going to be one more than the exponent that's given. It's not a bad idea to, you can use combination theory like this for every single term, but Pascal's triangle will make it a little bit easier. Bless you. So if you want to write that out. So it's 1, 1, 1, 1, 2, 1, and then the numbers they add from above. So 1, and then 1 and 2 is 3, 2 and 1 is 3, 1 and nothing is 1, 1, 4, 6, 4, 1. You see how I'm doing that? That makes sense? So this is what we're interested in. This is going to have 5 terms. This is in front of the first, second, third, fourth, fifth. So the first term is a 1, and then multiply. I don't need to put the brackets, but I'm going to just to make sure everything's separate. X to the power of what? Anybody? The X is 4, exactly. X to the power of 4. 5 to the power of what?
0.
Yeah, that's right. 5 to the power of 0. That's our first term. Plus, now we put the 4 in. X to the, now it goes down 1. X to the 3, the 5 goes up 1. 5 to the 1. I'm going to run into the triangle, so I'm just going to go one step down here. Now, it's worth mentioning this is +5, so really there's a plus in front of that 5. We don't typically write that, we don't need to, but I'm mentioning it now because if it's negative, we should put that negative in. It will show up. Same with the X. Okay, next term, 1, 4, 6. X to the 2, 5 to the 2. So once you kind of fall into the pattern, it's a lot easier. Next number is 4. Am I going too fast for anybody? X to the 1, 5 to the 3. Last term, 1, X to the 0, 5 to the 4. Do we need to write something to the 0? No, because that is 1. So like this is just 1. This is just 1. We don't need to write it, but I'm just showing you every single step. So now we simplify. X to the 4, we don't need to write a 1. 5 to the 0 is 1, so it's 1 times x to the 4 times 1, so it's just x to the 4. Plus 4 times 5 is 20, 20x cubed. For this one, 5 squared is 25. 25 times 6 is 150, so that's plus 150 x squared. 5 cubed, 5 times 5 is 25, times 5 is 125, 125 times 4 is 250 is 500. X, we do not need to write x to the 1. That's not really clear, is it? That feels blurry to me. Well, you can see it, but. So it was 500, and then 5 to the 4, 5 times 5 is 25, times 5 is 125, times 5, 625. Pardon? Did you just get electrocuted?
I was just saying it was 625.
Oh, you were. It came across like you were being swallowed by the Matrix or something. X to the 0 is 1, so 625 times 1 times 1 is 625. We cannot simplify this any further. This is lowest terms. X plus 5 to the 4 is the same as saying x plus 5 times x plus 5 times x plus 5 times x plus 5. And we could do it this way, kind of one at a time, do these two, then whatever answer, do this, then whatever answer, this. All kinds of simplifying. This rate would probably take a page of work. So this is the short version, the tricky, fancy, smarty pants version, the shortcut you're supposed to take. Does that make sense? Are we okay with that? Anyone? Home or abroad?
Just if we're finding the number for the exponent, I'm a little bit confused with that part.
Okay. It literally, we're just stealing it from here. So like to start, whatever the first term is, it'll be your first term in the binomial. That gets all of the exponent to start. And then from there, each time it goes down 1. So x to the 4, to the 3, to the 2, to the 1, to the 0. The other one starts at 0 and goes up by 1. 0, 1, 2, 3, 4.
Oh, okay.
Does that make
Yes.
sense? Yeah, so just find that pattern.
Mhm.
Honestly, I think the trickier part is knowing which row to use. But it's a big hint when, see, notice it goes like 2, 3, 4, and 5, 6. It'll keep going. Whatever the power is, that's the row you use. It'll be your second term. Okay. Ready for the next example? So this is top of 293, or sorry, bottom of 293. X minus 3 cubed. So it's given us 1 with a negative, so we can see what that business is all about. So we're going to use this row, right? 1, 3, 3, 1. Some of you might, because I know how your brains work, you might, as soon as you get the test, like flip it over or find an empty spot, and you're going to fire down that Pascal's triangle. I see the knowing smiles, which is cool. It's a great idea. Write it down once, and then you just use it whenever you need it to. So 1, 3, 3, 1, that's going to go in front of all the terms. So we have 1 x to the power of what? That's right, cubed. -3 to the power of what? Correct, 0. Plus, next number is 3. 3 x to the 2, -3 to the 1. Next number is 3. X to the 1, -3 to the 2. Notice I'm putting the exponents on the outside of the bracket. It's a good habit. Like 95% of the time, it's not going to bother you either way. But if I put this, technically speaking, if I put this 2 on the inside of the bracket, so it's -3 and the 2 is right here, technically speaking, the answer to that is -9, because that exponent is just attached to the number, not the sign. If we have it on the outside of the brackets, it means the whole thing. Now it's -3 squared. -3 squared like this equals -9. This one equals +9. Last one, 1 times x to the 0, -3 to the 3. Simplify. X cubed is, let me check my calculator, x cubed. Oops, I put a plus down when I shouldn't have. This one's going to be negative because we have this -3. -3 times 3 is -9, x squared. Now it's positive. -3 times -3 is +9. 9 times 3 is 27. Three times 3 is 9, times 3 is 27, so it's -27. X to the 0 is 1. So it's 1. Now both of these examples is x minus 3. This one, x plus 5. Both of these had a number in there. So if when it isn't, so if this is like an x and a y, you'll still see the 1, 3, 3, 1 in the final answer. You don't here because there's a number inside. If this was x and y, this would be x cubed minus 3x squared y plus 3xy squared minus y cubed. Questions? We doing okay? As is normal, and I know like you're not getting a whole lot of class time to do this, but you have tomorrow and Wednesday's class for review and all that other stuff, and to do this assignment as needed. I'm going to keep going through examples. I'm assuming that's necessary right now. If anybody feels like, I got this, let me go, then you are released to do the assignment. But I'm going to kind of keep walking through. Anybody still need this? We're good? Who left, do you think? Was it Micah or Matthew? Matthew, how dare you? Yeah, Matthew, usually the moment we're done notes is off to the races. Okay, so we haven't even used this yet for one of our examples, but we'll get to that with number 4. So I'm on page 293. Do you want me to do all the examples? Might as well. So question number 1, so this is page 293. Now notice, let me show you something. So it's got examples with solutions. So it says find the first 3 terms in the expansion of this. It's using what's it called? Combination notation. So you can use the combination notation if you want, or you can lean on Pascal's triangle. It's totally up to you. Okay. I prefer Pascal's triangle. It's done. I don't have to, because you're using if it's like 5/3 or whatever. Well, that is 5c3, which is 5 factorial over 3 factorial times 5 minus 3 factorial, blah, blah, blah. It's a lot of, it's not a lot, but it's some extra steps. If we're using our triangle, that I threw in the recycling. And somebody pick this up for me. Then we can just kind of go to the triangle and use it. Now this is asking, this first example is to the power of 5. So we need one more row here. 1, 5, 10, 10, 5, 1. Okay, 1 and 4 is 5, 4 and 6 is 10. That's how we're getting those. So this is the row that we're going to use for this question. It's asking for the first 3 terms of a plus 2b to the power of 5. So the row we're using from Pascal's triangle is 1, 5, 10, 10, 5, 1. So 1, bless you, 1 times a to the 5, 2b to the 0. It's a positive sign here, so it's all pluses. The next one is 5 times a to the 4, 2b to the 1. Anyone in the room here a little shaky on this? Like feeling not 100% confident?
There's 2 ways to do this.
Yeah.
Are we gonna be asked to do it one way or the other?
Like whether or not use the triangle or not?
Yeah.
No, it's up to you. So everybody in the room here is comfortable? So what's my next term? What do I start with?
5 or
10, yeah, because we took the 1, we got the 5, 10. Then a to the b, 2b to the, and it's all at one. This question just said the first 3 terms. So now we simplify. A to the 5. Okay, 2 times 5 is 10. A to the 4b. 2 squared is 4. 4 times 10 is 40. A cubed b squared. Any problems? Makes sense? Do you want me to do 2 and 3? It's more the exact same. It's just a little bit more complicated on the inside. It's 2x and 3y. Wants the first 3 terms. The next one wants us to do all the terms of 1 plus 3x to the 5th. Do you want me to do these? Do we need to, or can we skip to number 4? If you want me to, no problem. I just don't want to keep doing stuff if you guys don't need it.
I'm good with going to number 4.
Emma, you look a little undecided.
Oh, yeah.
You're good? You sure? You good? Okay. I don't want you guys to feel like, oh no, I can't say it now because everybody else wants. Too bad for them if you want me to do it. Okay, number 4 says, find the 4th term of x plus 3 to the 8th. 4th of x plus 3 to the 8. This is where this comes into play. The rth term, so r equals 4. So everywhere there's an r, it's a 4. So what we're going to do is I'm gonna rewrite this with our numbers. So 8c and then r is 4 minus 1, so it's 3. So it's 8c3 times a, or sorry, not a, it's x to the n minus r. I'll write the numbers in. So 8 minus 4 minus 1. And then 3 to the 4 minus 1. Oops. Which equals 8 factorial over 3 factorial times 8 minus 3 factorial times x to the 4 minus 1 is 3, 8 minus 3 is 5, x to the 5. No. Use your imagination. Sorry, you guys. Sorry about that. I don't even know how much you caught of that. Remember I said before I was put the exponents outside the brackets? I forgot. Any problems? You see where the substitution is happening? See where I got it from? You guys okay with this? Anybody lost?
What does it say, like the brackets on the end?
Over here?
Yeah.
Sorry, I crossed out because I had the 5 and the 3 on the inside, which I shouldn't have. So x to the 5, 3 to the 3.
Yeah.
I was just telling you guys the previous example or the one before. This is why we put them on the outside, and then I didn't. Okay, so we keep going. Simplify this. So 8 factorial, and this is going to be 5 factorial. So 8 times 7 times 6 times 5 factorial, all over 3 times 2, because that's 3 factorial, times 5 factorial. You know why I'm not doing 3 times 2 times 1, right? I don't want that to throw anybody. 3 factorial is 3 times 2 times 1, but we don't need to do the 1. Times x to the 5 times 3 cubed is 27. So the 5's cancel, 5 factorial, 5 factorial. The 2 and the 3 cancel with the 6. 8 times 7 is 56. 56 times 27 is 1,512. I didn't think of that. That's on the book there. 1,512 x to the 5. So this is the first example we've done of where you need this. When you need just one term out of an expansion. Now you could, what some students would do is they would do this x plus 3 to the 8. They would just expand the whole shoot and match and go, okay, this is the 5th term or whatever. Now this is one of the pros and cons, if you will, of the way we kind of mark things now. It's not just right or wrong answers. We need to know that you know how to do it this way. So if you provide the right term without doing it this way, then you don't get all the credit. Do you know what I mean? You need to know how to use this. So it's better than nothing. It's better to show that you know how to expand it and everything, but you should do it this way. Okay, one more example. The 6th term of blah, blah, blah. I'll just use this page. Try and keep it on the camera this time. Is it cold in here or is it me? This is my warmest shirt. I'm always warm when I wear this shirt. Got an undershirt and I got this thing. I'm cold. Okay, number 5. 6th term of y minus 2 to the power of 9. The 6th term. So in our, I'm running out of space with my triangle. Oh, I don't need to. What am I talking about? We're not expanding the whole thing. So 6 is r. So we have n, which is 9. 9, c, r is 6. So 6 minus 1. A is y. Y to the n, which is 9. Minus r is 6. 6 minus 1. And then b is negative 2 to the r minus 1. R is 6. 6 minus 1. Is that okay? Is that clear? So this is 9 factorial over 5 factorial and 9 minus 5 factorial. I'll write it down. 9 minus 5 factorial times y to the 9 minus 5, so y to the 4. Negative 2 to the 6 minus 1 is 5. You can always check. These exponents always need to add up to the main one, right? Always. So you can always just have a quick check. 4 and 5, 9. Yeah, okay, so I'm good. 9 minus 5. So 5 factorial is the big number here. So 9 times 8 times 7 times 6 times 5 factorial over 5 factorial times 4 times 3 times 2, because that's what 9 minus 5 is, 4 factorial. Times y to the 4, and negative 2 to the 5 is negative 32. Is that right? 2 to 2 is 4 is 8, 16, 32. So we'll cancel these 5s. 2 and 3 is 6. 4 goes into 8 twice. So 9 times 7 is 63. 2 times 63 is 126. 126 times negative 32 is negative 4032. Y to the 4. Yes, 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 you will get a calculator. This negative sign is important because we have a negative answer here. It's easy to forget. It's easy to miss. Cool, cool, cool. Hunky dory. We got a fair amount of questions to do, such as grade 12 pre-calculus math. This is exam week. Why are you here? What are you doing? Any other questions about anything? No, we're good. Ready to move along, little doggies? All right, I'm going to end this recording. Karina, you're good? Micah?
Yep, I'm good.
Yeah.
All right, we'll see y'all later.
Yeah.